Food production is responsible for about 1/4 of all greenhouse gas emissions in the world. And we know how climate-friendly diet looks like. But do we like its taste? Welcome to watch the Sustainability Trends in Business. Today we will talk about food. Food is one of the basic needs of any biological creatures, including us. Agriculture was a huge innovation disruption about 10,000 years ago. Jared Diamond called it the humanity's worst mistake because it led to a lot of negative outcomes in human health, social structures and environment. The number of hunter-gatherers was around 1 million globally, and now we're closer to 10 billion. 10,000 times as many as we used to be. And this has been largely enabled by very efficient agriculture. There is no shortage of food in general. Hunger has actually become rarer than it used to be. And I think Jared Diamond was right from sort of the environmental point of view. But now that we are 10 billion, we need to do, of course, something about feeding us. And the downside of food is that about 44% of habitable land area is used for agriculture, almost half. And it's almost 50 million square kilometers. And of course we use or abuse our seas as well. As a reminder from an earlier lecture, if we look at land vertebrates, land animals, dry biomass, humans are number 1, cattle number 2, sheep, goats, chickens. And that means that top 5, us and our food. 97% of mammal biomass is either us or what we eat. 71% of all birds are poultry, chicken mainly. So when we talk about land use and biodiversity, agriculture is the question number 1. On the other hand, agriculture used to be a relatively closed loop. So in the history, if we go back in history, we actually had a closed loop agriculture. People and animals ate agricultural products and then of course excreted something which was used to fertilize the fields, and round it goes. Apart from some land use issues, actually very little escapes this circle. And this sounds good, but it's also quite inefficient. If we didn't have fertilizers and machinery and modern agriculture, we would starve to death. Traditional agriculture takes way too much space. There is no space for it. There is no sustainable past we can return to with the current food production, so we have to go forward and innovate something new. But where do the greenhouse gas emissions come from in agriculture? And actually, this is a little bit the same answer as where is the land use or what is the land used for? But before going into numbers, I want to say that intuition is no good here. And there are wildly differing numbers available. I suspect that the large economic values associated with food production tend to be so large that their gravity bends the space so that the numbers will be bent as well. So again, double check, triple check. Just to give you an idea of food emissions, let me drive to a local hypermarket with my car, 10 kilometers there and 10 kilometers back. I buy a week's food for the family. What are the emissions and where are they? Well, with an electric vehicle, the electricity consumption for 20 kilometers is around 4 kilowatt hours. That is 0.2 to 2 kilograms of carbon dioxide, depending on the location here. In Finland it's about 0.2 or less. Anyway, we talk at maximum of maybe 2 kilograms of carbon emissions. Well, if I had a dino-fueled car, burning dead dinosaurs of course emits carbon, but it would be maybe 4 kilograms, so a couple of kilograms. Remember that one. Heating the market, the hypermarket, and cooling all the fridges and freezers consumes a lot of energy. That again depends on the energy efficiency of the hypermarket and energy production. But with a hypermarket with decent energy efficiency, we talk about the same as my EV ride, maybe 0.2 to 2 kilograms of CO2, so single-digit kilograms, maybe 1 kilogram. So before even buying anything, my visit may be worth a couple of kilos just by transporting myself and the pile of metal into there, and then being there in the heated premises with the cooled fridges. Bad, isn't it? Well, then I buy food. A kilogram of cheese, a few hundred grams of meat for my spaghetti bolognese, some apples imported from somewhere far away, and so on. What are the emissions of the stuff I plan to use to feed the family? Well, that few hundred grams of minced meat from beef may be worth 10 kilograms of CO2. Much more than my driving or heating the premises. The cheese, another 10 kilograms. Oops. And then we have the apples that come from very far away. Kilogram of imported apples, well, maybe a few hundred grams of CO2. That's surprising, but we'll talk about that later on. And so on. A lot of different items with wildly different carbon footprints. So driving the car or using a plastic bag is not close to the top of the list. It's not important. What is important is what I buy, what kind of food. The average carbon footprint for a Finn, and I think this applies pretty well to most Western Europeans, is roughly 5 kilograms of CO2 per day. So feeding a family for a week with the average diet gets into 3 digits, over 100 kilograms of carbon dioxide a week. But let's have a bit closer look at the emissions. Here we talk about AFOLU, agriculture, forestry and other land use. As a sector, sometimes it's called FLAG, forest, land and agriculture. It's approximately the same thing, but this graph gives one view into the question. There are emissions from several sources. Fossil fuels are used in agriculture, for example, logistics, or plowing fields with a tractor. Ruminant animals emit methane, CH4. Here it's called enteric fermentation, which is a beautiful word for cow burps and cow fart. By the way, humans as well may burp and fart methane, but our flatulence is up to 0.1 grams of methane a day, and half of people's won't emit anything due to the bacteria in their gut. Do you use that information for anything? I don't know. Fertilizer production is energy intensive, and then we use a lot of nitrogen-based fertilizers, and they decompose. And the bad thing there is that they emit nitrous oxide, N2O, which is a very strong GHG. Then agricultural land usually binds less carbon than, for example, forest. In the forest you have the trees, which bind a lot of carbon. But there are huge differences. In Finland, about 10% of field area emits 50% of all agricultural emissions, not only feeds, but animals and everything. Why is this? Because that 10% of field has been created by drying peat bogs, and it's decomposing by itself and emitting 35 tons of carbon dioxide per hectare per year. That's a lot. But fields can be made carbon sinks in some cases. So this is not black and white. One field is very different from another field, and having grass is very different from having, for example, wheat. This can be sliced and diced many different ways, but by looking at this, over half of the emissions are due to animals for our use. That, however, is not the full picture, because there are things like rice fields which are responsible for almost 10% of all emissions because they emit a lot of methane. Wet fields. I want to warn that food is a complex issue, and the emissions come from a large number of streams. The numbers vary from one source to another, one reason being that the same food grown on another field may have a completely different footprint. Here is one view of emission intensity of different foodstuffs. Beef has the highest emissions, largely due to high methane emissions, but also land use is important. It requires a lot of land to feed cattle. That, of course, depends on where they graze. Sometimes they may graze on lands that couldn't be used for anything else, grasslands, for example. Lamb, on the other hand, it's very good from the land use perspective because, I mean, if you've seen lambs in, say, Iceland or New Zealand, you know that they just roam around and they don't need any specific agricultural land. But unfortunately, they have high methane emissions as they are ruminant animals. But not cow fart, it's lamb fart. When we say animals are bad and plants are good, the picture is a bit more complicated because eating pig or chicken may be only 1/10 of emissions of beef, as pig and poultry don't ruminate. There are no huge methane emissions. And interestingly, then we have nuts. I go nuts over this because nuts may have a negative footprint, and this sounds crazy, but the point is that nuts are currently being grown on trees that are being planted on land that used to be fields, which means that they actually bind carbon. All this points to the basic wisdom. If you want to remember one thing, we shouldn't eat meat or other animal-based products. We should replace them by plant-based product. And while this holds true in the big picture, we just managed to forget a couple of important aspects. First, there are 3 different arguments against eating animal products. We have the environmental, climate change, biodiversity, which is due to land use and methane emissions. And that, of course, is a bit more nuanced as discussed before. Second perspective are the ethical questions. Is it okay we use animals for our own food? We just grow something, kill it, and eat that dead animal. Is it okay? This is a value-based cultural question which can be discussed for a long time, but let's not spend that long time here. And then the third argument against meat is nutrition. We know that eating a lot of meat has a correlation with several diseases, so meat in general is not necessarily very healthy. But that is also an argument which has more than one side. Different animal products are different, and different plant products are different. Beer, potato crisps and candies are often products without any animal-based ingredients, but that doesn't make them very healthy. Anyway, 3 strongish arguments against eating animal-based products. Why do we eat them? Well, again, there are reasons, at least 2 important reasons. First, they provide proteins needed by us, so a nutritional reason. Plant-based proteins are a more complicated question, often resulting from a lot of processing, as most plants have quite little useful protein. Second, sorry, but animal-based products taste good. At least many people think so. And this may sound trivial, but taste is a very strong cultural driver. And also food, regarding culture, food is part of our identity. We may be meat eaters, or we may not touch meat at any cost. And then yet another factor to notice, let's get back to our previous bar graph. If you look at the emissions, they are measured in kilograms per kilograms, so kilograms of carbon dioxide per kilograms of product. And that doesn't make sense, does it? You can't replace one foodstuff by another foodstuff kilogram by kilogram. Also, the food may be carbohydrates, it may be fat, it may be protein, and different qualities of them. So these should be compared as categories instead of just lumping everything together. Even then, plant-based protein is better than animal-based protein. However, there are large variations between plant-based protein sources. Peas, nuts, and soybeans are great. Some calculations indicate that the carbon footprint of oat milk would be the same as cow milk per protein, up to 10 kilograms per 100 grams of protein. This is because oat doesn't have that much protein, and the same applies to almond milk, soy milk, rice milk. There are no huge differences in emissions per protein. But there is again a good counter-argument to this. Per liter of product, the emissions of plant-based products are smaller because they have much less protein. And then counter-argument, if we aim at having a certain amount of protein, the comparison per protein is valid. Then again, do we? In general, we eat too much protein in the Western world. That can actually be measured from the wastewater because the nitrogen comes through. Maybe double our need. But as you can see, if this was only an exercise to feed all people with healthy food and sufficient energy, but not too much, it would be much easier. Our nutrition is far away from healthy or optimal, but it is a matter of taste. In the comparison of carbon footprint and energy content, the emissions of sugarcane sugar are maybe 0.5 kilograms per kilogram. We need in average a bit more than half a kilo of sugar a day to cover our energy need, and that would give total emissions of 0.3 kilograms of carbon dioxide a day, next to nothing. That is probably the most climate efficient food. Or if we take oil, Finnish rapeseed oil has a highish carbon footprint of 2.7 kilograms per kilogram, but to cover daily calorie need maybe 0.3 liters, that is 0.8 kilograms of carbon dioxide per day, it's not much either. And if we take our protein from peas, that would be maybe 0.3 kilograms of carbon dioxide a day. So altogether, by combining these, would be way less than a kilogram a day. But this is a bit theoretical. We could also slash our food footprint by eating less. We eat too much in average. Why don't we? Because eating is fun, it tastes good, and it gives some emotions, something. It's a cultural thing, it feels good. We don't eat unhealthy or environmentally bad way because these foods would be unhealthy or environmentally bad. No. And here we come to the core of modern sustainable food technology, FoodTech. The main challenge here is protein. Carbohydrates can be tackled, fat can be tackled pretty easily. There are a lot of solutions for proteins such as insect protein, but obviously there is something to be done to gain social acceptance. Would you eat this? One philosophical question is how we try to replace animal-based products. We may try to mimic them closely as possible, like plant-based meat. But the challenge there is that in that competition you can only get a second place, or then you need to invent something new. An example of emerging business in this field is Volare. Volare's idea is to take all sorts of side streams, that is waste, and feed it back to black soldier fly larvae. These nice little larvae produce protein, oil and fertilizer. After they have grown, they are just squeezed, you know. It's not for human consumption, but it's great for pet food and, for example, fish in aquaculture. Another innovation is bioalbumin by Onego Bio. The idea is to create egg protein without animals. The process is a fermentation process, a bit like making beer. Sugar plus some nutrients are fed in, then a genetically modified fungus excretes this albumin egg white protein, and the end product is used in baking, and it's a one-to-one replacement for egg white. Then solein is another protein. It is also created by microorganisms. Here the specialty is to get the ingredients from thin air. You only need carbon dioxide, you get carbon from that, nitrogen, hydrogen from water, and then you have electrolysis and all that kind of stuff. You add a small amount of mineral nutrients, and all you need is there. Air, water, energy. Obviously, this can be made down to negative emissions because it binds carbon. And then we can get more protein by using our animal-based food better. Superground has technology to grind chicken and fish bones into high-quality smooth protein. And that should have the same protein composition as meat and even pretty good taste. It's intended for human consumption. There are loads and loads of these, which is great. One thing that seems to be in common with these very ambitious innovations is that they don't make any money today. They are run on venture capital money. Of course, a great thing because then we develop new technology, which we sorely need. But the main problem there is not the technology. The main problem is that animal-based protein is extremely low cost. Our animal agriculture is so efficient that protein is cheap. We would need carbon pricing for agriculture. That would accelerate decarbonization a great deal. Also, one thing to remember is that targeting the climate conscious or environment conscious people may not give very high impact because they already usually eat quite climate friendly. If you can reduce the meat consumption of a high meat diet person by half, so someone who eats a lot of meat eats a bit less meat, the emissions will be reduced way more than if you can convince a low emission diet person to only eat water. Of course, proteins are not the only problem. Social innovations to reduce beef eaters' beef consumption could be very impactful. New ways of cultivating land could dramatically change land use emissions and even give us carbon binding. There are many significant emission sources where it is possible to make an impact. Complicated? Sure. Needed? Sure. Business opportunities? Well, the World Bank estimates food is at around 10% of the global GDP, and there will be and there needs to be a huge disruption. The question is what kind of and when, but business opportunities, definitely. This is all for this episode. Bon appétit!